In this video, we will discuss the definition of continuity. A function f of x is continuous at x equals a if the following three conditions are satisfied. Condition number 1, f of a is defined, meaning we should be able to take any number x and plug it into the function and get a real defined number. Condition number 2, the limit as x approaches a of the function must exist. You can check out my video on when a limit does not exist if you're curious. And condition number 3, the limit as x approaches a of the function must be equal to the function value defined when x is a. Let's explore whether the function f of x is continuous when x equals a. In this case, x equals 1. Condition number 1, we must find f of 1. Looking at the graph, when x is 1, the y value plotted is -1. Condition number 2, we have to take the limit as x approaches 1. So we're going to consider two things. The limit from the left, the limit as x approaches 1 from the left of the function is headed to 3. And the limit as x approaches 1 from the right. And that one's headed to -1. Since these two quantities are not the same, since the one-sided limits are not the same, we have the limit as x approaches 1 of the function that does not exist. So we have not satisfied condition number 2. Since that's the case, we have discontinuous when x is 1, and this type of discontinuity is jump. What about when x is 3? Let's go through the conditions here. Condition number 1, f of 3, looking at the curve, we're going to get f of 3 equals 1. Find the limit as x approaches 3. This one's headed to the same quantity from each direction, from the left and from the right. So we'll say that limit is equal to -1. And then condition number 3, we need to do the comparison step. We need to compare the limit as x approaches 3 of the function, which we just found to be -1. And that quantity is not equal to 1, which is the function value evaluated at 3. So we have not satisfied condition number 3. Since those two quantities are not the same, we have discontinuous again. And this type of discontinuity is called removable. What about when x equals 4? Taking a look at x equals 4, it looks like there's a vertical asymptote going on there. So going through the process here, when you attempt to evaluate f of 4, we get an undefined value. So we have not satisfied condition number 4. So this must be discontinuous. This is also called an infinite type discontinuity. This type of limit as well. Another way that you could see it, if you were trying to find the limit as x approaches 4, we would say that limit does not exist because it's an infinite type limit. So either way you think about it, the function is definitely not continuous when x is 4. Lastly, we have x is 5. Looking at the curve, it appears as if the function is continuous at 5, but we won't know for sure until we've established it through the three conditions. Condition number 1, f of 5. That point plotted is equal to 1. Condition number 2, the limit as x approaches 5 of the function. Coming from each direction here, we are getting +1. And then our comparison step, we found the limit as x approaches 5 of the function was equal to 1, which was the same thing as the function value at 5. Because we've established all three of those conditions, that means this function is continuous when x equals 5.